Okay, today we're going to talk about tree diagrams, but before we go into that, let's go over a warm-up with significant figures. They're going to talk about this on the IB test. So, rounding to three significant figures. So you can see I've highlighted the three significant figures, the 9.47. If the last digit that's not highlighted is above 5, then we round it up. So you can see we've rounded the 7 up to an 8. Here we've rounded this 0 up to a 1. Here we've rounded the 7 up to an 8. Okay, here we didn't round up, so we have 5.32. And here, this is an important one. The second 9 is significant, but since this third 9 here is greater than 5, it rounds everything up. But in order to make it three significant figures, you have to have two zeros after the decimal, and that's always significant if you've got two zeros after the decimal. Same thing on this question D. They're asking you to determine the number of significant figures. So this 0 that's written here is significant because they bothered to put a 0 after the decimal. Okay, hit pause and listen to this again if you need extra practice on this. Okay, so here they talk about Lee's archery target practice, and if she hits the target, it's 3/4 probability, and if Lukey hits it, it's 4/5 probability. So if she hits the target 3/4, so missing it has got to be 1/4 because these two have to add up to 1. You either hit the target or you don't. Okay, and then same thing with Lukey. You either hit the target or you don't. So 4/5 hitting the target, 1/5 not hitting the target. And there's four possible paths: hit, 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 don't hit, miss and hit, and miss and miss. And so with all four pathways, they add up to 1. Okay. Another thing, instead of using hit and miss, sometimes they'll use a little prime, which means the opposite. So I could have done H and H prime. So in this example, they're talking about the car starting 80% of the time. So here I've got capital C for the car starting. And when the car doesn't start, I'm going to call this C prime, indicating the car does not stop. Oh, one other thing. Notice that I'm using highlighters to explain what I'm doing. If you use highlighters, your notes are going to be much more clear than if you don't. And it's very important to draw your tree diagrams. So anyways, 80% of the time the car starts. So clearly it's 20% the car doesn't start. Right? These add up to 1. And then the motorcycle only starts 60% of the time. So starting the motorcycle, so not starting has got to be 0.4, right? Because these two have to add up to 1. So not starting the motorcycle, I'm calling that M prime. So let's look at question I. Both will start. So C, so if I'm going this route where the car starts and the motorcycle starts, I multiply 0.8 times 0.6, we get 0.48. The Carl can only use the car. So the car starts and the motorcycle doesn't. So 0.8 times 0.4. These are the answers. Okay. Let's talk about this one here. So they've already made the tree diagram for you. P stands, so box A and box B is where the flowers come from, and P if it's going to be purple, and W if it's going to be a white flower. So if you look at box A, there's 2 purple flowers and there's 4 white flowers. So that's why this is 2/6, and then this here is 4/6. Okay. And for box B, there's 5 purple flowers and then 1 white flower. So the question is, what's the probability of getting a purple flower? So you're either going to have box A in purple, or you're going to have box B in purple. So the probability of box A in purple is 1/2 times 2/6. And the probability of box B in purple is 1/2 times 5/6. And so this is the probability of A in purple, this is the probability of B in purple. You add those two probabilities together, and that's the probability that you're getting purple in general. We're going to have the same thing happening here on 1B. Okay, so they wanted you to finish the diagram. They said 0.6 that you're female, so clearly it's going to have to be 0.4 that you're male, because these have to add up to 1. And then it says 20% of the females and 30% of the males play violin. So 20% of the females play violin, so this is going to have to be 0.8, because these two have to add up to 1. 30% of the males play violin, so that's going to be 0.3, so this is going to have to be 0.7, because these two have to add up to 1. So, question I, what's the probability that a male that does not play violin? So male not playing violin, 0.4 times 0.7 gives me this. Okay, the probability of playing the violin. So you're either going to be female in playing violin or male in playing violin. So 0.6 times 0.2 is going to give me 0.12, and then 0.4 times 0.13 is going to give me 0.12. Add these two together, and that's the probability that some human plays violin. Next one. Okay, you've got jar A with white and red discs in it, and jar B with white and red discs. And a jar is chosen at random from flipping a coin. So if you're flipping a coin, you've got a 50-50 chance of getting heads or tails and picking jar A or jar B. Okay, so so you got 50-50 chance of getting jar A or jar B. Now, if you get jar A, you have 2 white and 3 red discs, so you've got 2/5 chance of getting a white disc. If you're, and then you have a 3/5 chance of getting a red disc, because 2/5 plus 3/5, that's going to give me 1. Okay, now jar B has 3 white and 1 red disc, so 3/4 and 1/4. Once again, these add up to 1. Okay, so the question is, determine the probability of getting a red disc. So if you go this path, heads and red, you got 0.5 times 3/5, or 0.6, which gives me 0.3. If you go this route, it's 0.5 times a quarter, right? 1/4, which is 0.25. So this gives me 0.3, this gives me 0.125. Add those two probabilities together, and that's the probability of getting the red disc. You may want to hit pause and rewind and watch this if you have questions on it. Okay, I'm going to go over question 3 last, because I want to make sure we get question 8. Okay, question 8 says that, okay, we've got 3 bags. To pick a bag, we're going to roll a die, and if you roll a die, this is a die, right? You roll it. And then what they're saying is there's 6 sides on the die. Okay, so 3 sides of the die have the letter A, 2 sides of the die have the letter B, and 1 side of the die has the letter C. So I'm going to write this as 3/6, 2/6, and 1/6, because this is the number of sides that the die has the letter A on. Okay, you may want to hit pause and think about that. Okay, now if I've got bag A, I've got 3 red and 2 blue. So 3 red, 2 blue, 3/5, 2/5. Bag B, 4 red and 1 blue. So I'm going to write 4/5 and 1/5. These, and then if I look bag C, I've got 2 red and 3 blue. So I'm going to write 2/5 and 3/5. Okay, so question 1 says, what is the probability that we've got blue? So you're either going to get bag A in blue, bag B in blue, or bag C and blue. So this first route, 3/6 times 2/5, well, 3/6 is 1/2, right? So 1/2 times 2/5 is going to give me 1/5. And then 2/6 times 1/5 is going to give me 1/15. Okay, you can see here I wrote 1/3 because 2/6 is 1/3. Okay, and then the bag C, 1/6 times 3/5 is going to give me 1/10, right? You can simplify the 3 and the 6. Okay, then we have to get a common denominator. So getting a common denominator means 30 is the common denominator. So 1/5 becomes 6 over 30, 1/15 becomes 2 over 30, and 1/10 becomes 3 over 30. We add these together, and that's the probability of getting blue. Now, you could have done the same thing for getting red, or you could simply say, hey, if it's not blue, it's going to be red, isn't it? So I could do 100% minus 11/30, and I'm going to get 19/30. Once again, you can hit pause and replay and watch this over and over to get to hear this again. All right, let's look at question 3. Okay, so we do a spinner, and 2 parts are black, 1 part yellow, and 1 part red. So we got 50% chance of getting black, 1/4 of a chance getting yellow, 1/4 of a chance getting red. And so we can fill out this tree diagram. 0.5, 0.25, 0.25, 0.5, 0.25, 0.25, 0.5, 0.25, 0.25. Okay, so what is the probability of getting black both times? So 0.5 times 0.5 gives me this blue pathway, which gives me 0.25. Question C, what is the probability of getting yellow twice? So I'm going to get 0.25 times 0.25, which is going to give me this. Question D says, what is the probability that you're going to get different colors each time? So I thought to myself, well, let's figure out the probability of getting red twice, and you'll see why I did this. 0.25 times 0.25 is going to give me this value, and that's the probability of getting red twice. Now, if I add these colored ones, getting blue or black twice, getting yellow twice, getting red twice, the probability of getting the same color twice is this. If I do 1 minus that value, that's the probability of getting different colors every time. Okay, you may want to hit pause and think about that for a second. Okay, lastly, question E. What is the probability that black will appear on either spin? So if I go this pathway, all 3 of these pathways I'm going to get black at least one of the times. So this pathway plus this pathway plus this pathway is going to add up to 0.5. Now, if I look at this one, so if I want to get black going this pathway, it's going to be 0.25 times 0.5, and that's going to give me 1.25. And if I look at this additional pathway, let's see, if I get red and black, right? So I have 0.25 times 0.5, and that's going to give me 0.125. So I've got the blue pathways here giving me a black. I've got this one yellow pathway, yellow and then black. And then I've got this red pathway and then black. So if I add all of those together, this is the probability of getting at least one black when rolling. You may want to hit pause and replay for ones that you have trouble with. I hope this helps.